Alright, welcome to Probability Without Replacement Level 1. Now in our very first example, we're going to be using a standard deck of cards, which will always imply 52 cards. And we want to know what are the odds of drawing 2 jacks without replacement. Okay, so what is this idea of without replacement? It's where we pull a card out of the deck, and rather than putting it back in, it's like we throw it away. Okay, it's no longer in the deck of cards. So if we had 52 cards and we pull one card out, well, then 52 goes to 51. Now we need to know some things about cards. So I'm going to write right over here. This is going to be kind of our card key. And the first thing we need to know is what is a value card? Well, a value is anything that's an ace, a 2, a 3, all the way to a queen or king. All right. So, and then you ask yourself, well, how many of them are there of each? Well, there's 4 aces, there's 4 twos, there's 4 threes, there's 4 fours, there's 4 eights, there's 4 jacks, there's 4 kings, there's 4 of each. And so what we'll say is, okay, well, for any type of value, it's going to be 4 out of 52. Now, then after a value, the next thing we have are the suits. All right. And what are the suits? Well, our suits are we have hearts, we have diamonds, we have spades, and we have clubs. Now, for each suit, you could either say it's 1 out of 4, or I think a better way to think of it with probability without replacement is that for the hearts, well, there are 13 hearts out of 52 cards. If I were to ask you how many diamonds are there, there's 13. Why? Because each one of our value cards, there's 4 of each, because there's 4 suits. And so, if I ask you how many aces are there, well, that means there's 4 aces, and there's an ace of hearts, an ace of diamonds, an ace of spades, an ace of clubs. And so if there's 13 value cards, well, then there must be 13 of each suit. Now let's put this into practice. So example 1 says, using a standard deck of cards, what are the odds of drawing 2 jacks? Well, we want to ask ourselves, are jacks values or suits? And in this case, we know that they are values, both of them. And so we'd say for our first jack, and for probability without replacement, it really does help to label it like this. For our first jack, there's a 4 out of 52 chance of pulling a jack. But what about our second jack? And this is where probability without replacement gets a little bit tricky. Well, if there were 4 jacks to begin with, you took 1 out, that 4 drops down to a 3. And if there were 52 cards in the deck to begin with, and you took 1 out and you threw it away, well, now we know that there's going to be how many cards? 51. Perfect. And so now we have our 2 probabilities. And in order to multiply these, we know that for fractions, it's just top times top. So 4 times 3 would give us 12 over 52 times 51. Now I would encourage you to grab your calculator for that, where 52 times 51 is 2,652. Now, this can reduce, or we could turn it to a decimal. So let's see, we could do 12 divided by 2,652, and that would actually give us 0.0045. And the way you turn that into a percent is we always move our decimal 2 places to the right, and it turns out there is a 0.45% chance of that happening. And you can see the answer is either a fraction or a decimal, so let's get in the habit of writing down both. Now let's go ahead and talk about example 2. Example 2 says this: a bag of marble contains 10 red marbles, 6 black marbles, and 8 blue marbles. And we want to know what is the probability of drawing 2 red marbles in a row without replacement. Well, the first thing this problem doesn't tell us is it doesn't tell us explicitly how many marbles are in the bag. So we're actually going to have to figure that out ourselves. We know that there were 10 reds plus 6 black plus 8 blue. And then we would ask ourselves, what is 10 plus 6? 16 plus 8, and 16 plus 8 would give us 24. So anytime we draw any one of these marbles out, well, we're drawing that number out of 24. So let's see. Our very first red marble, we know that there are 10 reds, and let me go ahead and label that first red. And you know what? Let me kind of do this. Let's actually switch colors. So now we have our first red is going to be 10 out of 24 times, and then I'm going to write my second red. And look, this is what probability without replacement is. We pulled out that red marble, and I just want you to pretend we flicked it away. It's gone. So if we started out with 10 red marbles, we threw one away. How many do we have now? Well, obviously we have 9. And if there were 24 marbles in the bag to begin with, and we pulled one out and threw it away, well then of course that would go down to 23. So let's go ahead and do our math here. We have 10 times 9, which is of course 90, over, and then on this one, definitely use your calculator. What is 24 times 23? And that would give us 552. Now, that reduces, so you can type that into your calculator and reduce it down, or we could actually go ahead and find the decimal and the percent. And so let's see, 90 divided by 552 will give me 0.1630. And so if I move that decimal 2 places to the right, well, that would equal 16.3%. So once again, you can write your answer of probabilities as either a decimal or a fraction, and you need to be able to do both. Okay, well, I hope so. Now, for example 3, let's read this problem. It says, using a standard deck of cards, once again, we know that's 52. What are the odds of drawing a jack of hearts and then a spade without replacement? Well, let's real quick write down our card key. We know that whenever we have a value, that will always be 4 out of 52. Whenever we have a suit, that will always be 13 out of 52. And then I'm actually going to add one more category here. What about when we have a value of a suit? And so what is a value of a suit? Well, that would be like a jack of hearts. It's whenever they say a value and then a suit all on one card. They're getting really specific. Well, that would just be 1 out of 52. Because in the entire deck of cards, there's only one jack of hearts. Another couple examples, there's not only one ace of spades. There's one 7 of hearts. There's only one of each suit. So, let's go ahead and look at this. I want to write my first card. And so my first card that we're asked to be drawn is a jack of hearts. Well, let's see. Is that a value, a suit, or a value of a suit? And of course, it should be pretty obvious it's a value of a suit. So there's only going to be 1 out of 52 jack of hearts. Now let's go ahead and write down our second card. And once again, I think it really does help to label these in some sort of way before you write down your probabilities. Now, this one is where it gets a little tricky. How about a spade? So ask yourself, is a spade a value or a suit? And in this case, we know that it's a suit. Now, usually that would mean we would write down 13 out of 52. However, remember, we pulled a jack of hearts out of the deck and essentially threw it away. So when we pulled out that heart, well, we know there's still going to be 13 spades because we didn't change the number of spades, 13. But when we pulled out that original jack of hearts and didn't put it back in, our entire deck of cards went from 52 to 51. And so now we can go ahead and figure out what this is. So let's see. So we know that 1 times 13, of course, will be 13, over, and then let's see, 52 times 51 would give us 2,652. Now remember, you can put that in your calculator and reduce it by dividing it down, or we can go ahead and find the decimal. Let's see, 13 divided by 2,652 is 0.0049. And so once again, to go from a decimal to a percent, we move our decimal twice to the right, and of course it would equal 0.49%. All right. Well, I hope this helps, and I'll see y'all in our level 2 video.